Hi, I'm Mary Frances McDaniel, and I attended the lecture titled The Coffee Ring Effect and the Physics of Breakfast by Professor Peter Juncker. I chose this lecture because I love breakfast food and thought it would be interesting to hear the physics behind some of my favorite foods and beverages. Professor Juncker began by discussing the coffee ring effect, which is the noticeable effect of darkening around the edges of spilt coffee, which is well known to any accident-prone coffee lover like myself. This effect can actually be seen with any dissolved liquid with something suspended in it, however. Professor Juncker then went into detail about what exactly coffee is, oil and small particles from coffee grounds dissolved in water, and the fact that it is a solution, emulsion, and suspension, which I found fascinating as it was a reminder that even something as simple as a cup of coffee has very complex physical properties. Professor Juncker explained that the main physical properties controlling the coffee ring effect are surface tension, adhesive forces, and pinned edges. He explained that his lab studied these properties by creating a suspension of colloidal particles or spherical or plastic spheres suspended in water. The suspension's particles were small enough to follow the flow of liquid and yet large enough to be seen under a microscope so as to allow the individual particles to be tracked. Surface tension is the cohesive property of molecules towards each other, or, as Professor Juncker explained, their desire to sit close to one another. Surface tension minimizes surface area so the molecules move from the surface to the interior until the substance settles into a sphere, the shape that most reduces surface area. Why then is spilt coffee not in little spheres? This is due to coffee molecules' adhesive properties, or the force towards the surface, which spreads the drops out into a spherical cap in which the edges are pinned to the surface. Then, as the water evaporates more quickly around the edges where the drop is not as thick, a fried egg shape should ensue. However, this shape has a much higher surface area, and thus the molecules are pushed towards the edge to recreate a spherical cap, carrying the things dissolved with them and leading to the infamous coffee ring. Next, Professor Juncker began to discuss eggs, my favorite breakfast food. Professor Juncker began his discussion of eggs by asking why, when heated, water evaporates, but eggs, which when raw supposedly act like a liquid, harden, which, I kid you not, I had been pondering a week or two before. To start to address this odd phenomena, Professor Juncker's lab used the universal testing machine to confirm that scrambled eggs do indeed behave most like a solid, and raw eggs do indeed behave most like a liquid. So then why do eggs harden when heated? Professor Juncker then explained that eggs are mostly water with a little over 10% protein suspension. Proteins have both hydrophobic and hydrophilic regions, parts that dislike and like water, respectively. When raw, these proteins fold in distinct patterns so the hydrophobic ends are touching and away from the water, and that the hydrophilic ends are touching the water. When this protein suspension is heated, it denatures these proteins, causing them to unfold and then refold with different pieces sticking together as hydrophobic regions bump into each other and stick together to create a conglomeration of proteins, or scrambled eggs. Professor Juncker ended by discussing cereal, which creates a meniscus in the milk due to its adhesive properties. Because the cereal is less dense than the milk, it wants to be as high above the milk as possible, and thus the few pieces left in your bowl try to climb each other's meniscus and thus decrease the potential energy as they come together. Although I found all of Professor Juncker's talk very interesting, as it reminded me that we are surrounded by fascinating science and even things as simple as coffee, eggs, and cereal, I was most fascinated by what this knowledge is now being used to create, such as malaria and Alzheimer's tests that are based on the coffee ring effect. The basic idea of these tests is to take blood, dilute it with a mix, let it dry, and then by looking at the spot left behind, one can see if the person tested has the disease, and thus if it is worth the time and money for them to travel the sometimes very long distance to get treatment. These tests would be very easy to administer and would be fairly cheap. They are still, however, being tested. This talk reminded me that science is a very universal subject, and the information we garner in one field is often even more useful in application in other fields. Thank you very much for listening.